So before we get into like any sort of notes, I think we're gonna just go over some stuff for the quiz. I know it's been a while since Friday. It feels like forever for me. So let's just get started on reviewing for the quiz. And I gotta get myself set up. All right. So we started out this class. I don't have like any guided notes for this or anything. We're just doing some review. We started this thing called hypothesis testing, where we basically like have this situation and we think something might happen. So we have a like null hypothesis in the beginning that we think is going to happen. Then we're kind of skeptical about it. So we do a little experiment in real life and we collect some data. And then once we interpret the data, we either reject the null hypothesis or fail to reject the null hypothesis, right? Now that conclusion can either be the right decision or not the right decision, depends on that chart that you will be given on the quiz. And let's kind of just go through each of like the sort of quiz type questions and see where we're at. And I think this will be a good review for what we do today. Okay, so I kind of wrote something out here. And I know the question on the quiz is going to be a little bit more applied. It's going to have like a situation to it. But I was kind of lazy, so I didn't come up with a situation. Let's just say the mean of something is 200. We just think it's 200. Fine. And this researcher thinks the mean is actually shorter. So maybe we're measuring the length of something. Okay. We're going to be asked what the null and the alternate hypotheses are. So that's like one of the questions that you could see on the quiz. Okay. So this is asking us to write the null and alternate hypothesis. Does anyone remember the symbols that we use for these? And what about the alternate? H1, good. Okay, so your answer to these questions, of course, have to use these symbols, right? H0, H1. And we usually like put colons after them just to be like, here's the null hypothesis. Here's the alternate hypothesis. Okay. Now, what is the symbol that's used in these? The Greek letter. Mu, good. We're always talking about the mean. So we're always talking about the mean. And the null hypothesis always has a certain symbol, either equals, less than, greater than, not equal to. Which one is it? Equal for the null hypothesis. Good. Okay. What do you think the mean equals for the null hypothesis? 200, good. Or it depends on the question, but yeah. This one, it should be equal to 200. And the alternate hypothesis always has the same number, right? So it's going to be 200. Okay. Do you think it's going to be bigger, less than, not equal to? Less than, right? Because, well, it says shorter. Shorter means less than. Cool. Okay. Any questions on this example here? All right, let's take a look at a different type of question. I don't know. A different type of question could give you maybe the null and alternate hypothesis in the question. So I don't know. Let's say H0 is mean equals 5. And H1 says that the mean is bigger than 5. Okay. Now this might, the quiz is probably going to be a little bit different, like give you a scenario. But let's just say we reject the null hypothesis. Okay, so we want to state the conclusion. Okay, remember our conclusion is always going to be a sentence. It's going to be composed of 2 parts. So I'm just going to write part 1, part 2. Okay, part 1 depends on the question, depends on if we reject or fail to reject. What is part 1 of our sentence if we reject the null hypothesis? We conclude, good. And I usually like say that so it flows a little bit better. Okay, what is part 2 always going to be? The alternate hypothesis. Now, this doesn't depend on the question. It is always going to be the alternate hypothesis. So H1 is mu is bigger than 5. Okay, so no matter what the question, it's always going to be the alternate hypothesis. Okay, how about we do the same scenario, But in this case, what we're going to do is we're going to fail to reject the null hypothesis. Okay. So same scenario. Let's construct our sentence. It's going to have a part 1, a part 2. What do you think is going to go in part 1 this time, Peter? Yes, there is not enough evidence, oh gosh, to conclude that. And what goes in part 2? Alternate hypothesis, same thing. Mu is bigger than 5. Okay. So I know it sounds a little weird. Statistics is kind of nitpicky. You always have to like say the right thing in the right way. But if you can construct your sentence in part 1, part 2, remember to put the alternate hypothesis in part 2, you will be fine for the quiz. Any questions on this example here? Cool. All right. Let me just do one more. Okay, something like maybe your last question on the quiz. Okay. The last question always depends on a chart, and I will give you the chart, so don't worry. Okay, so this is what it looks like. HO true, HO false, reject, HO, fail to reject, HO. Okay. So I know you don't have to memorize it, but just think about it. If we reject something that's false, we've made a correct decision, right? And if we fail to reject something that's true, that's got to be correct too, right? Okay, and if we reject something that's true, we said that was a type 1 error. And if we fail to reject something that's false, we said that was a type 2 error. So let's just put this into practice on a certain type of question. Let's just say that we were given a scenario, might be a little bit more wordy, but the scenario says that the mean is equal to 50, and the alternate hypothesis said that the mean was, I don't know, not equal to 50. Okay. Let's say, so basically what we're doing is we're setting up this experiment and we come to a conclusion. We don't know if the conclusion is actually true or not true, but we might make an error. Okay, so let's say the true mean, or let me not use the word true, the actual mean is not equal to 50. Okay, but we, oh, let me use the word and, sorry. And we, I don't know, fail to reject. Okay, this question is going to ask you, is this a correct decision? Is it type 1? Is it type 2? Okay. I know it sounds kind of stupid, but I like to write out everything before I come to a conclusion here. Let's just start with the beginning. It says that the actual mean is not equal to 50. So is HO true or false? False. Good. Because, well, HO says that it's equal, and if it's not equal, then it has to be false. Okay. If we fail to reject, well, that's easy. Fail to reject. Okay, let's take a look. HO is false. We fail to reject. This is a type 2 error. Okay. All right. Everyone feel good for the quiz at the end of class? Nice. All right, I think that was a good introduction to what we're about to do now. So we're actually going to start a new set of guided notes for today. So let me pass these out. All right, so all of last week we've been talking about this thing called hypothesis testing, and I feel like we've just been talking about like a bunch of random stuff, and you don't really see the point of making the conclusion and stating your hypotheses. You don't really see how they kind of go together. So what this section is going to do is we're actually going to combine everything together in a streamlined process. So we're able to make a hypothesis, do a test, and then, well, decide if we reject or fail to reject, and then write our conclusion all in one piece. Okay, so what we're going to learn is we're actually going to learn this thing called the p-value method, and I'm actually going to check this one. And this is going to give us a little idea on how to piece everything together. Now, before we do this, I like to kind of put all my information in the front. So if you ever get confused to what a symbol is talking about, you can always look back here. Okay. So in this section, we will always have a null hypothesis. Okay. Now, for reference, we talked about this in the quiz review, but the null hypothesis always is going to have an H0. You're always going to have a colon. And since we're talking about the mean, we'll use mu. And it's always going to be equal to something, right? So these questions are going to give us a scenario. Our null hypothesis is going to look like this. Next, we're going to have an alternate hypothesis. Alternate hypothesis, H1. We're still using mu, but it could be bigger than, less than, or not equal to some other number. I think we're all pretty good at that. Okay, questions in this section will also give us the population. And let me write this down here. It might give us the sample standard deviation too. Okay, so just write that in your notes. You might have the population or the sample standard deviation. Can anyone give me the symbol of either the population or sample standard deviation? S is the sample, good. And what about the population? Yeah, it's the cherry one, right? It's actually called lowercase sigma, but I like to think of it as the cherry symbol. Okay. So we got the population standard deviation or the sample standard deviation. Next, we're going to construct an experiment. An experiment always has a sample. What is the sample size? N, good. And since we have a sample and we're doing an experiment, we're going to get a sample mean. What's the symbol for sample mean? X bar, good. Okay, so we're going to do all this stuff. We have all these symbols flying around at us. The general idea behind this is once we construct our experiment and we get the sample mean, we're going to compare the sample mean in our hypothesis. Now, think back at this. When we did the card example, we had these cards, we had a hypothesis that was not even close to what we concluded at the end, right? We did an experiment and we got some sort of result from that. Basically, what this is telling us is we're comparing the result from the experiment to our hypothesis in the beginning. We're going to see how strong it is. If it's strong enough, we can like fail to reject, or if it's not strong, we can reject the null hypothesis. Okay, now how do we do that? We're going to use this thing called the p-value. Okay, don't really worry too much about what the p-value is. Basically, it just comes from this thing called the normal distribution, right? We talked about, and we kind of use the central limit theorem to find it. Okay, that's pretty much all you got to know about this. If you want to talk to me more about the p-value, totally fine, come to my office for that. But that's where we're going to kind of leave. Okay, the p-value is just going to be one number. And if the p-value is very, very, very small, we have a lot of evidence to reject the null hypothesis. If p is really big, then, well, we fail to reject the null hypothesis, okay? So I know that doesn't make too much sense right now. Let's do a few examples, okay? I think the hardest part about p being large enough or small enough to reject or fail to reject the null hypothesis brings on the question, well, how small is small enough to say, okay, we're going to reject the null hypothesis? And how big is big enough to fail to reject the null hypothesis? This depends on this thing called the significance level. Okay, so the significance level is this letter alpha. Okay, every single question is going to give you the significance level. You will never have to like figure it out on your own. This is just going to tell how strong we want the relationship with between, oh my gosh, the sample mean and our null hypothesis. Okay, so this is just this line that determines how small enough we should get to reject the null hypothesis. Okay, technically it describes the top 100 times 1 minus alpha % of the sampling distribution. You don't have to know that. Just know significance level alpha. Here's where things get kind of cool. If our p-value that we end up calculating, we haven't gotten there yet, but if p is going to be less than alpha, so p is really, really small, we're going to reject the null hypothesis. Okay. I actually meant to take this out. Sometimes we call this statistically significant. Okay. And if p is bigger than alpha, we're going to fail to reject. So either do not reject or fail to reject. HO, they mean the same thing. So let's do a couple examples. Okay. Let's say that our p-value is 0.0122. That's pretty small, right? Well, if it's small enough, it actually depends on the question. Okay. So here's example number 1. Okay. Let's say that alpha in our question is telling us that the significance level is 0.05. Now, this might sound like the dumbest thing ever, but I like to write everything down, and I know you might want to do this in your head. Totally fine with me if you do it in your head. This is what I like to do. I want to compare p to alpha, so I'm going to write p. I'm going to write alpha, and underneath p, I'm going to write what the p-value is, 0.0122. Okay, under alpha, I'm going to write what alpha is in the question, 0.05. Okay, and I always write p on the left, and I always write alpha on the right. It sounds dumb, but I swear to God, it helps me a lot for making a lot of mistakes. Okay, which one's bigger, p or alpha? Alpha, good, right? 0.05 is bigger than 0.1. So I'm going to put a big less than sign here. And let's take a look at that blue box. Since p is less than alpha, do we reject or fail to reject? Reject the null hypothesis, good. So that is how our decision is made. Any questions on our p-value? So not too bad. I know it sounds really stupid, but sometimes I just like to write it down. Try example 2, and we'll come back in a tiny bit. Oh yeah.
So write the alpha symbol like the same way as up there.
It doesn't really matter to me, but you don't really have to write anything if you feel comfortable with it. I just like doing this because I make a lot of dumb mistakes when I do math. Walking around. So here we go. Example 2, p alpha. I know it's kind of stupid to write them down, but that's how I do this. P is the 0.0122 still. And alpha is 0.01. Okay. Which one was bigger, p or alpha? P, good. Put my sign that way. And since it was bigger, then we do not reject, right? Fail to reject. Okay. So p can be really, really small. It can even look really small, but depending on the question, we can either reject it or fail to reject the null hypothesis. Okay, not too bad, right? Awesome. Let's put everything together now. Okay, when we do a hypothesis test, there are a few steps that we have to follow. Okay, step 1, we're going to state our assumptions. Now, this is basically the same thing as we did with the confidence intervals. But since we're doing p-values, we're still using the central limit theorem. I kind of touched on it a little bit when I introduced the p-value. We use the central limit theorem to get to this. But for now, let's just know that we have to use the central limit theorem, which means we have to check if the sample size is large enough, bigger than 30, or if the population is normally distributed. Step number 2, we're going to have to look at the question and state the null and alternate hypotheses. Okay. Step number 3, you might be like, okay, how do I get this p-value? Amy's just going to calculate the p-value using a software. Now, if you are in 155, Math 155, you'll kind of learn how to use Minitab to get this p-value. For this class, I'm just going to go in my software and click it just because, well, we don't really have access to computers for tests and stuff. So I'll do that. Step number 4, decide if we reject or fail to reject the null hypothesis based on our p-value and our alpha value. Step 5, we're going to write a conclusion saying we conclude or not enough evidence. Okay. Any questions before we try an example? All right. Now, the thing with these questions is they get very, very large, which I'm not a big fan of. But let's just see how this goes. Okay. Let's say that the mean height of adult men in the US is 70 inches, with a standard deviation of 3 inches. There's a sociologist who believes that taller men might be more likely to be promoted. So they think that the mean height of male business executives may be greater than the mean height of the entire male population. Then a simple random sample to test this of 100 male business executives have a mean of 73. We're still assuming that the standard deviation is 3. We want to see if the male business executives are taller on average than the general male population. Okay, that was a mouthful. And this is why I like to write down all our information before we get started, just so we have it all on the front page. Okay, so my page over, let's see. Okay, what I like to do for these questions, I know that I'm going to have a population mean and sometimes a population standard deviation. I also know I'm going to have stuff for the sample. Let me just write all my stuff for the population first. Okay. So population stuff. We have a population mean, which is mu, right? And well, in this question, we have 2 means. We have 70 and we also have 70.3. Which one is the population mean? 70, right? It's just like the mean height of everyone in the US is 70. That sounds like a population. Over here it says like sample. So let's say 70 is our population mean. Okay. Let's see. We also have standard deviation, which is 3. Is there standard deviation the population or the sample? I hear sample, I hear population. Anyone want to explain why they think the way that they do?
Yeah, I think that population is in the same sentence as the.
Yeah, it's in the same sentence. I think the people who are saying sample have seen it like later in the question, but it does use the population standard deviation symbol, so I would go with population here. Actually, doesn't really matter for this question, but let's do 3. Okay. So we've kind of went through everything with the population. Let's go to sample stuff. Okay. Well, usually with samples, we're always given the sample size. How big is our sample? 100, good. Next, we're going to talk about a sample mean, which is X bar. And what does the sample mean? Awesome, 70.3. Okay. And I guess alpha here is 0.05. So I'm just going to write alpha off to the side, just so I know it's there. So what we've done is we just kind of tabulated everything down, so we don't have to go back in the question and look for everything later on in the question. Okay. So let's kind of put this into perspective here. Mean height is 70, and someone thought it might be bigger for like a group of male leaders or whatever. So we took a sample of 100 people. And the sample size does seem like it's a little bit bigger than the population. So we're going to see if we reject or fail to reject. It's kind of, mine's kind of blurred here, not really sure if that's enough to reject the null hypothesis. Let's see what the p-value says. Okay. So first, we have to state our assumptions. I think we only have one assumption to look at, and we're going to check to see if the sample size is bigger than 30. Well, is it bigger than 30? Yeah, right? So 100 is n. That's bigger than 30. So we are good. What do you think we would do if it wasn't bigger than 30? Yeah, go back in the question and see if it was normal. Cool. Okay, so that's it for step 1. All right, step 2, stating the null and alternate hypotheses. This is where things get a little bit wonky, okay? We have to go back into the question and kind of see where these are at. Okay. Null hypothesis. Remember, H0 colon mu equals. That's always what our null hypothesis looks like. Alternate hypothesis, we'll have the same number, but it'll be a different symbol. So I'll just set that up. What do you think mu is equal to in the null hypothesis? TJ?
70.
And how did you get that?
Like our information that said that population 70.
Yes, right.
It's not looking at the sample.
Good. Now some people will tell you to like look back at the question and be like, oh, what do they say before the sociologists came in and made their claim? I'd say just go into the information up on the top. We have the symbol for mu, it equals 70. It's already there. All right. Any questions on how we got 70? All right, so mu equals 70. All right. Remember, the alternate hypothesis is always going to have the same number, but it's going to have a different symbol. Okay. Let's take a look at the question. Do you think it's going to be bigger, less than, not equal to? Bigger. Why do you say bigger?
Because what the third, fourth line says, the mean height of male business executives may be greater than the mean height of the entire male population.
Yes, we have the word greater. We also have the word taller here, right? So whenever you go with these questions and you're trying to find the alternate hypothesis, go in the question, see if you can see something that says larger, bigger, like shorter, less than, something like that. That will tell you which symbol to use here. Okay. So we're going to use big. Cool. Any questions with the null and alternate hypotheses? Cool. Let's go to step number 3. So basically what I did is I went into my computer. I used this software called Deviation. Now, if you have time, towards the end of the semester, I'll show you exactly what I did here. But I basically do this test, and it really tells me what the p-value is. It literally states it right here. So based on this output, it says p-value, and well, below it gives me my p-value, 0.15. If we have enough time at the end of the semester, I'll show you exactly what I put. It's actually kind of cool. I wish we had computers in this classroom. That'd be kind of fun. But that's what we're doing for now. Okay. Step number 4, we're going to decide if we reject or fail to reject the null hypothesis. And we do that by comparing our p-value to alpha. Okay. P is 0.159. Anyone remember what alpha was? Good, 0.05. Which one's bigger? P. Oh, it's actually P, right? That's why I put them next to each other, because sometimes it's hard for me to look at them and see which one is bigger. Even then, I still make mistakes. So at least I make less mistakes now. Okay. P is bigger. So do we fail to reject or reject? Fail to reject. Good. So we fail to reject the null hypothesis. Finally, all we have to do is write our conclusion now. Remember, our conclusion has 2 parts. Okay, part 1, part 2. If we fail to reject, do we start with we conclude or not enough evidence? Not enough evidence, good. So there is not enough evidence to conclude that. And what is always our ending? H1, good, the alternate hypothesis. So looking back at the alternate hypothesis, it says mu is bigger than 70. I'm just gonna rewrite that down here. Mu bigger than 70.